Hello, everybody. The topic that we shall be discussing today is the Black-Scholes option pricing model. The Black-Scholes option pricing model, which is also known in the short form as BSOP. Now, what exactly is this Black-Scholes option pricing model? So let's just have a quick discussion about this Black-Scholes option pricing model. Now, before I discuss about this Black-Scholes option pricing model, I'm actually going to discuss something about the option. That what exactly is an option? We have actually seen the concept of options. We do come across currency options. We do come across the interest rate options. And we do know that what exactly is an option. Option is a sort of a derivative which actually gives you a right to buy. Option gives you a right to buy or a right to sell something. Like the option does not create an obligation. Option gives you a right to buy or option gives you a right to sell. Now, when we talk about the concept of the option, there are few things that actually need to be understood. First of all, the types of option are the options are generally classified into the call options and into the put option. Now, what exactly is the call option? What exactly is the put option? So when we say the call option is an option to buy, and the put option is actually an option to sell. So when we talk about the call option, when we talk about the put option, it's an option to buy, it's an option to sell. The options can actually be classified into the various categories. The various categories could be the options could actually be the European style options. The options could actually be the American style options, and they could be the Bermudan style option. Now, what exactly are the three different types of options? So let's have a quick discussion about these three types of options. When we talk about the options being European style option, this actually means that they can only be exercised. They can only be exercised on a specific date. On a specific date. When we talk about American options, the American style options are actually those options which can be exercised till maturity, which can be exercised till maturity. Whereas when we talk about the Bermudan style option, the Bermudan style options can actually be exercised in specific periods up till maturity. Now, what exactly do you mean by this? Now, let's just understand. Whenever you come across an option, whether it's a currency option or whatsoever option is there, you would actually have an option, you will have an expiry date of that option. The expiry date or the exercise date of the option could be, let's say, it is 31st December 2018. Now, the European style option would actually be exercised only on 31st. If we talk about the European style option, it would only be exercised on 31st. If we talk about the American style option, it can be exercised up to 31st December on any day. And when we talk about the Bermudan style option, the Bermudan style option could actually be, let's say, exercised from 1st to 5th, 11 to 15, 20 to 25. So basically, it's actually certain time intervals up till the maturity date that these options could be exercised. So up till now, we have actually gone through the basic concept of the options, which is the options give you either a right to buy or a right to sell. They can be call options, which is the right to buy. They can be put options, they can be right to sell. The options could be various style, European style, American style, Bermudan style. Now, let's move forward and let's just discuss few more things. Like for example, we could actually say that the entity has an option to buy, and the entity has an option to buy $1,000 at the rate of euro 1.0.75. Now, what exactly is this? This option to buy makes it a call option. The dollar is basically called underlying. What is exactly an underlying item? Underlying item is an item on which the option is actually given. So it's the option is actually given on this currency dollar. This is actually termed as the strike price. This is actually termed as a strike price. So when we talk about the options, we have got the type of option. Number two is the underlying. Number three is the strike price. And there are a few more things. And what exactly are those few more things? Few more things that actually are considered when we actually discuss the options, and that actually is uh, the expiry date of the option. The expiry date of the option, the date up till which the option will expire. So now, basically the important thing is to understand that how exactly do we value these options. So when I talk about the valuation of the options, so Black-Scholes option pricing model is one of the models that helps you in the valuation of these options. Now what we are going to do is that we are going to start discussing the formula for the Black-Scholes option pricing model and discuss that what exactly is this model all about. So when we talk about the Black-Scholes option pricing model, you are being given this formula in the exam conditions. You are being given this formula in the exam conditions. So what exactly is the formula of the Black-Scholes option pricing? The formula of the Black-Scholes option pricing model, which is C, which is the value of the call option. The Black-Scholes option pricing model, which is actually the value of call option. The value of call option, it says PA is the current price of the underlying asset. PE is the exercise price. R, which is the continuously compounded risk-free rate. So the risk-free rate is R. T is the time to expiration measured as a fraction of 1 year. For example, T is equivalent to zero point 0.5 means expiration is in 6 months. E is the exponential function and N is refers to the normal distribution rate. Now, how exactly do we apply this Black-Scholes option pricing model in order to value the option? So the first step, what we are going to do is that we are going to discuss a very basic concept. Now, what exactly is this very basic concept? So let's actually discuss that how do we actually establish that very basic concept. Now see, so let's take this example, which is it says, consider the situation where you have got what exactly is the situation where the stock price 6 months from the expiration of an option is $42. The exercise price of the option is $40. The risk-free rate is 10%, and the volatility is 20%. The volatility is 10-20%. This means that PA is 42, PE is 40, R is equivalent to zero point 0.1, S is equivalent to zero point 0.2, and time period is zero point 0.5. Now, what exactly is going to happen? How exactly are we going to value this options using the Black-Scholes option pricing model formula? So the first thing that we will have to do is that you need to see this formula. This is PA and D1, PE and D2. Now, what we are actually not aware of is what exactly is this D1, what exactly is this D2. Because till the time we don't have D1, until the time we don't have D2, we can't actually calculate and D1 and D2. So you're also being given the formula in the exam of D1 and D2. So the first thing that I'm actually going to do is that I'm going to calculate D1. So the D1 is ln PA upon PE. What exactly is PA? PA is basically the value of the underlying divided by PE, which is the exercise price, plus R, which is actually 0.1 plus 0.5 into S square, which is zero point 0.2 square, multiply by zero point 0.5, because the time period is actually zero point 0.5 because we've got 6 months to expire. And then S, which is zero point 0.2 under root 0.5. So when we are actually going to solve this equation, so the value that you're going to get is, so it gives us ln 1.05 is this 0.048. Is actually ln 1.05 is 0.048 plus, so the numerator is actually 0.158, whereas when we talk about the denominator, it's actually going to be what? It's going to be 0.14142. So we have got, this is Okay, so the answer that we get from this is actually 1.1172 4. So this is what the D1 is. Now let's talk about D2. When we talk about D2, so D1 is going to be 1.11724 minus 0.2 under root zero point 0.5. So if I talk about this minus, so you end up getting D2 as 0.9758, 0.9758. Now, what do we have? We have got the value of 1.1124 for D1. We've got value of 0.9758 for D2. Now, what exactly do we need to do? We need to actually find the value of ND1 and we need to find the value of ND2. How exactly are we going to find the value of ND1 and ND2? So you need to understand that there is actually ND1 and ND2 means that this is the value of D1 using the normal distribution table. This is the value of D2 using normal distribution. Generally speaking, what happens is normal curve is like this bell shape. So it starts from 0, this is zero point 0.5 and this is actually 1. So in the exam, what we are being given, we have been given the formula sheet where we have been given the sheet for this half of the curve. So if we have been given the sheet for half of this curve, so basically we have been given this type of normal distribution table. Now if we have been given this type of normal distribution table, so how exactly do we do things over here? First of all, what we are going to do is that we're going to find this D1. So if I'm going to find D1, it's actually 0. It's actually 1.17. It's actually 1.17. So if I say 1.17, how exactly am I going to find this 1.17? I'm going to say 1.1 here. So it's 1.17 here, 1.17 here, which is 0.379. Now, remember this thing, if D1 slash D2 is greater than 0, then you need to add 0.5 to it. And if D1 slash D2 is less than 0, then you need to deduct 0.5 from it. Now what exactly is going to happen? So when we talk about this 1.1, so we're going to say that ND1 is actually going to be 0.5 plus 0.379. So how exactly is it going to be? 0.5 plus 0.379 will actually gives you 0.879. Similarly, when we talk about the ND2, so what exactly is the value of D2 over here? The D2 is 0.9758 or 976. So what is exactly going to happen? 0.9, and what happens is 0.97 here. So we have been given 0.976. So the value is going to be somewhere in between. So let's say that I am actually saying that it's actually 0.98. So I'm just putting it 0.3365. Now, what is going to happen? 0.5 plus 0.3365 gives you what? It gives you 0.8365. Gives you 0.8365. Now, what next is it? If I discuss further, so what exactly are we going to do? We now need to actually calculate the value of the call option using this formula. So how exactly are we going to calculate the value of call option? It is actually going to be TA, which is going to be 42, multiplied by the ND1 has a value of 0.879. 0.879. Then you have got the minus sign, and the minus sign is this PE, which is 40, and then you've got ND2. The ND2 is 0.8365. 0.8365, and then you need to multiply it with the exponential power minus 0.5 into 0.1. So how much is it all going to be? So let's actually talk about it. Okay, so we end up getting the value of the call option as $10. So we end up getting the value of the call option as $10. So now, first of all, what exactly is this Black-Scholes option pricing model? It's a model to value a call option. What type of call option is it going to be? It is going to be the American style call option. It is going to be the American style call option. When we talk about the American style call option, so this is how we do it. The first thing that we do it is basically we calculate the value of D1 using this formula, and then we have the value of D1. We calculate the probability from the normal distribution table. Then we calculate the value of D2. Also, we calculate ND1 and ND2. ND1 and ND2 is actually input into this whole formula, so we end up getting the value of the call option. Now, what next is there? Once we have the value of the call option, the next step that we need to do is that we need to actually apply this whole into the application of the real life option. So I hope that this is clear with respect to the valuing the call option using the Black-Scholes option pricing. At times, what happens is the examiner requires us to calculate the put options. So if we actually have to calculate the put option, the value of the put option, so in order to calculate the value of the put option, this formula will be used, and this is also given in the examination. So like if for example, if I have to calculate the value of put option, I would first of all calculate the value of the call option, which is $10 in this case, and then minus whatsoever that is. So basically that ends the concept of the calculation of the Black-Scholes option pricing model. Now in our next lecture, what we are going to do is that we are going to apply these Black-Scholes option pricing model into the valuation of the real life options. Thank you very much.